I'm Emily Abbott from the American Chemical Society. Welcome to this media briefing from ACS Fall 2022. Unfortunately, pollution is everywhere. Cars, factories, power plants. It's unavoidable in our technology-ridden worlds. And many studies have shown it disproportionately affects communities where economically disadvantaged as well as Hispanic, Black, and Asian people live. The other side of the technology coin has allowed us to better monitor the pollution sources with more detail and more frequently. Today, scientists report preliminary work calculating how inequities in exposure fluctuate from day to day across 11 major US cities. And they show that in some places, climate change could amplify these differences. We're joined today by Dr. Sally Posetti, the primary investigator of the study from the University of Virginia, to talk more about her team's research. Thanks for joining us.
Thank you.
What an interesting study. What inspired you to ask such a profound question? How does air pollution differ from neighborhood to neighborhood?
Well, we started doing this work because it's important, and also because we sort of came at this problem as from the perspective of analytical chemists, and really thinking through the details about what our observations can and cannot say.
How did you select the cities to monitor?
So this work has started, this is work that's really built on years of work to think about what we can see from space and going through a lot of the details of the observations. And so we've in part thought about what type of other observations exist in cities. And so the work I'm going to share at the ACS meeting this year, we focus first on New York City and Newark. And the reasoning for that is that we have really detailed observations there that took place in the summer of 2018, where we had some aircraft observations that mapped NO2 pollution or nitrogen dioxide pollution at a spatial resolution of 250 meters by 250 meters. So we have this really detailed image of how pollution varies. And so we use those very detailed airborne observations as a standard of comparison in order to think in order to really sort of understand what we can see daily from space. So that's where we started, was we had those observations. They were already collected by NASA. And then, so as with the cities with work I'm gonna share at the ACS meeting, we thought about other major cities across the United States, but we also thought about selecting cities in different climate regions so we could think about how air pollution inequalities may scale in the future.
When you say air pollution inequalities, what do you mean by that phrase?
Yeah, so specifically, we're talking about differences in neighborhood level pollution that are experienced within cities on average between Black and African Americans, Hispanics and Latinos, Asians, and then non-Hispanic whites. We also think about inequalities in terms of poverty. So looking at neighborhoods that are below the poverty line versus above, and then also thinking about the combined effects and looking at inequalities for people of color living below the poverty line compared to wealthy white residents.
So data is collected from space and compared to or verified with data collected from an airplane. Are the data from the two mechanisms ever drastically different?
So the main difference between the airplane and the satellite observations are the observation resolution. And we can think about this as the difference between a high resolution image and a low resolution image. So high resolution images have very sharp edges, they have very small pixels, we can see a lot of detail very clearly. Low resolution images are pixelated often, they're somewhat blurry, and so we can see with less detail the image itself. And so this is the main difference between the observations. But it turns out we take observations that were collected at the same time and in the same place throughout New York City and Newark, and we find actually that when we look at inequalities throughout the city, we largely get the same answer. We certainly lose some information with the loss of resolution, but mostly we capture 75 to 90% of the inequalities across the city.
Your team identified diesel trucks as a possible cause for pollution fluctuations in research that you published last year. From these new data, do you have any city-specific theories or hypotheses about particular sources of pollution that could be addressed by some local municipalities?
So in this work, we weren't focused on identifying the sources of this NO2 pollution. Instead, we're looking more to see how these inequalities co-vary with other factors related to air quality and climate. So one thing that is relevant here is we do have a lot of observational evidence for the systematic overburdening of communities of color and low-income communities. So that's something that we can see in the data.
Can you talk a little more about the relationship between the future of air pollution imbalances and the future of wind and heat patterns as a result of global warming? What should we as a society be concerned about?
Yeah, so what we've been able to do, we use the daily variability in these NO2 inequalities, and we can now see how they vary with factors like winds and temperature. And so first with winds. So what we find is that we see higher inequalities when the wind speeds are slow. Okay. And so this makes sense because if we have pollution being emitted from a source, that pollution will be blown downwind and dispersed when the wind speeds are high. But when the wind speeds are low, it's going to stay more localized over that pollution source. And so because pollution sources are more likely to be located in communities of color and low-income communities, that causes more of a burden of pollution under those conditions. And so we can look in many regions across the United States. It's predicted that atmospheric stagnation is going to become more prevalent with climate change. And so this gives us a sense for how air pollution inequalities are going to scale. So as atmospheric stagnation becomes more prevalent, we're going to see worsened inequalities. With temperature, what we find is that temperature and NO2 inequalities are they're statistically significantly but weakly related. And what that means is that we have high NO2 inequalities on days with high temperatures, but also on days without high temperatures. And so what this means is that as temperatures warm, we're going to have days with high NO2 inequalities and more days with high temperatures. And so we would expect then greater cumulative burdens because of the change in temperature with climate change. I think then, in terms of sort of what I would want to say in terms of what we should do, it's just we really need to regulate. We need to target emission controls in communities that are overburdened by sources.
What's next for you and your team? Continue to evaluate areas you started to monitor, branch out to more locations, or some balance of the two?
I think both. Since we've shown here that we can use the daily satellite observations to describe inequality, this opens up a lot of opportunities for ourselves and for others. And the first is that we don't need extremely high resolution data in order to capture these trends broadly across the city. So that opens up avenues for different satellite instruments, for various types of chemical modeling. We really have a lot more tools open to us if these coarser resolution observations give us information. And the other thing is that when we think about air quality and we think about climate, our understandings of these from sort of from an atmospheric chemist standpoint, this is dynamic, right? We think about this as changing with time, from day to day, seasonally, and now we can think also very dynamically about how inequalities change. For health researchers, this is going to be important as well, because we don't generally experience annual average air pollution concentrations, right? We move through the city, we experience high concentrations at different times, and those things are going to co-vary with other factors that affect our health.
So how can a city or a town participate in future studies by your team?
Well, we're very happy to work with local partners, particularly community organizations. So we would be more than happy to speak with any community organization that wanted to collaborate and use these data.
Great. Thank you so much, Dr. Pasetti, for sharing your research with me today.
Thank you.
Be sure to check out our other media briefings for ACS Fall 2022, which will be posted throughout the meeting at www.acs.org/ACS Fall 2022 briefings.